You all can give your attendance. See, once again, I'll repeat. What was the difficulty in release method? Can anyone tell? Difficulty in release method?
It is only used to solve up to only 3 to 4 variable.
Correct. It is only used to solve up to 3 to 4 variables. Beyond 4 variables, it is a very tedious method, time consuming method, and sometimes we may get stuck up while solving the equations, simultaneous equations. Yes or no? As the number of variables go on increasing, it becomes a laborious work. You may get stuck up in between. You cannot express by you having only 3 equations and to express in other unknowns. Okay, it's very difficult, and to overcome this difficulty, the next method has come into existence. That is what we call as a Buckingham Pythagora method. In Buckingham Pythagora method, you can solve by having n number of variables, 1,000, 10,000, lakhs together variables. If you are having, you can solve. That is the advantages of Buckingham Pythagora method. Everywhere this method is been using in an experimental analysis or in a research work, they will be using the Buckingham Pythagora method. What it tells, what is the statement of Buckingham Pythagora method, how it can be used to analyze the problem, we'll see stage wise. Okay, with these 4 examples you can practice by taking other examples also. You can refer previous year question papers. Many a times the release method will be asking and also the procedure will be asking for release method. You can write the stepwise the procedure, how to solve the problems and all. And Buckingham Pythagora method is very, very important also for the examination point of view. Even if you are doing any research work and all there, if you want to solve any equations, or if you want to arrive certain equations by having a certain variables, you can use the Buckingham Pythagora method as a tool to solve the problem. It's very simple and very interesting also. As you know, previously we have solved some of the problems by using the release method, just by playing with the dimensions of MLT, fundamental dimensions MLT. So likewise you can solve the problems by using the Buckingham Pythagora method. So here just I'll show you. You all can see the screen?
Yes, sir.
What is been written on the screen?
Methods of dimension analysis.
Okay, methods of dimension analysis. See here, as I discussed previously, if the number of variables involved in a system, the physical phenomenon, are known, if you know the variables, how many variables are involved, if you know the number of variables are involved, then the relation among the variables can be determined by using the following 2 methods. See here, the phenomenon of the relation can be release method and the Buckingham Pythagora method. So this method is used for determining the expression for a variable which depends upon the maximum 3 or 4 variables only. If the number of independent variables becomes more than 4, it is very difficult and to find the expression for the dependent variable, as you have seen previously when we have solved the problem. Okay, so these problems we have solved. You can refer any textbook and take the problem and just go on solving the problem. You will understand. Okay. So now I'm taking the next method. This one, the Buckingham Pythagora method. This method, Buckingham Pythagora method. See, what is the Buckingham Pythagora method? The release methods of dimension analysis becomes more laborious if the variables are more than the number of fundamental dimensions. Means if the variables are more than number of fundamental dimensions, because we are getting for each fundamental dimensions one equation. For M also we are getting 1 equation. For L also we are getting 1 equation. For T also getting 1 equation. Suppose if there are 3 variables and 3 equations, we can easily solve the problem. If the unknowns are more than 3, this is very difficult to solve. So this difficulty is overcome by using the Buckingham Pythagora method, which states that if you write the statement of the Buckingham, this is a statement. If there are n number of variables, independent and dependent both together, they are called as n number of variables. If there are n number of variables, independent and dependent variables in a physical phenomenon, and if these variables contain m fundamental dimensions, that the fundamental dimensions are what? M, L, T, then the variables are arranged into n minus m dimensionless terms. Each term is called as pi term. Okay. So are you taking this statement, all of you? Are you writing?
Yes, sir.
Please write this statement, because this is very important statement. When I start solving the problem, you will understand this statement. So at this time moment, you may not be understanding what exactly the statement of Buckingham, but as I solve the problem, you will understand the statement. At least you remember the statement here. So when we are going for Buckingham pi theorem method, when we
if more numbers of variables are present.
Exactly, if number of variables are more, where the release method fails to solve the problem, then we go for the Buckingham pi theorem method. And what is the statement of Buckingham? You write this statement from here to till here. You write the statement here till here. You write the statement. If there are n variables, both together, independent and dependent variables together are called as n number of variables in a physical phenomenon, and if these variables contains m fundamental dimensions, m, L, T, then the variables are arranged into n minus m dimensionless terms. Each term is called as pi terms. This is the statement of Buckingham. The entire problem depends on the statement of this Buckingham. Okay. Now let us take an example. Suppose this is an example. They're explaining with the example. Suppose x1, x2, x3 up to xn are the variables. Suppose these all are variables involved in a physical problem. Let x1 be the dependent variable among these variables. See, these are the variables involved in a system. Out of these variables, x1 is considered as a dependent variable, or you may consider x2 as a dependent variable, and rest all been taken as an independent variable. So what is dependent variable now? X1 is dependent variable, but what is the definition of dependent variable? As we required certain information about that variable which depends on these other variables. Okay, here x2, x3 up to xn are the independent variables on which x1 depends. Then x1 is a function of x2, x3, xn, and mathematically it is expressed as, please all of you write this expression. This is very, very important for the examination point of many a times. It will be asking, write the Buckingham theorem statement as well as give the expression. Okay, this is the example. Okay, write x1, x2, x3 up to xn are the variables involved in a physical problem. Out of these variables, x1 be the dependent variable, and x2, x3, xn are the independent variables on which x1 depends. Then x1 is a function of x2, x3, xn, and mathematically it is expressed here. Once you come to know which is dependent and which all are independent variables, then it can be expressed as x1 is a function of this one. Okay, then let us call this is equation number. Okay, so x1 is a function of this one, that is x1 is a function of x2, x3, xn. And this equation can also be written as, just to take the x1 on this side also and equate it to 0 like this. So a function of x1, x2, x3 up to xn is equal to 0, means all together you take, these all are together to be taken and equated to 0. And now this equation is dimensionally homogeneous now. So dimensionally homogeneous, we have made it dimensionally homogeneous like this. Okay. And it contains n number of variables. It contains n number of variables. It includes both dependent as well as independent variables. If there are m fundamental dimensions are involved, means there are n number of variables. In n number of variables itself, there are m number of fundamental dimensions. M number of fundamental dimensions. How many fundamental dimensions are there? How many fundamental dimensions are there?
7.
7 are there. But as of now, we are using how many? As of now, we are using in this subject, how many fundamental dimensions we are using?
3.
3. Exactly, 3. We are using only M, L, T. Okay. Only 3 fundamental dimensions we are using, and those fundamental dimensions we are getting from the available variables. See, dimension homogeneous, it contains n number of variables. Among n number of variables, m fundamental dimensions are there. Then according to Buckingham-Pythagora method, this equation can be written in terms of number of dimensionless groups, or that dimensionless groups are called as pi terms. Remember, dimensionless groups are called as pi terms, in which number of pi terms is equal to n minus m. Remember, number of pi terms will be n minus m. Hence, the above equation becomes, so once we know how many number of variables are there are n number of variables. Out of n number of variables, m number of fundamental dimensions are there. Then the dimensionless groups can be expressed as n minus m. Suppose 10 variables are present in a system. How many dimensionless groups you get? Suppose n equal to 10. How many dimensionless group you will get? Now, what is the value of m? What is m?
Fundamental dimensions.
How many are there fundamental dimensions?
3, sir.
3. 10 minus 3, how many?
7, sir.
7.
What are the 7 dimensionless groups you will get? See, I am explaining there are 10 number of variables. Out of 10 variables, there are 3 fundamental dimensions we are having. Then according to Buckingham-Pythagora method, there are n minus m dimensionless groups you will be getting at last. They are called as a pi terms. Means in advance we come to know how many dimensionless group will forming. At the very beginning you are getting 10 number of variables. If you are getting 10 number of variables, at last final equation, how many dimensionless group you will get?
7. 7, sir.
The statement itself saying if there are n number of variables, in that n number of variables, if m fundamental dimensions are present, then the dimensionless groups are being expressed in terms of n minus m. Just I am saying here example, if there n equal to 10, m equal to 3, how many dimensionless group you will get? How many you get?
7, sir.
7. Those 7 groups are called as pi terms. Those 7 groups are called as what?
Pi terms.
Pi terms. That is Buckingham-Pythagora method. Means before solving the problems, you are getting a solution. So in release method, you are getting like this. Well in advance, are you getting how many dimensionless group are forming?
Sir.
No. That was the drawback of release method. You are not getting how many dimensionless group I am getting at last. But in Buckingham-Pythagora method, well in advance, before solving the problem itself, you will come to know how many dimensionless groups I am getting at last. You can cross check later also while solving a problem. So this is the advantage of Buckingham-Pythagora method. So once you get the number of pi terms you are getting, and those pi terms will be expressing in terms of a functional relationship like this. Did you understand?
Yes, sir.
See, look here. Once I come to know there are n number of variables, m fundamental dimensions, then those are expressing in pi terms. They are called as n minus m. So if, for example, 10 are the variables, 3 are the fundamental dimensions, 10 minus 3 are the 7 pi terms I should get. Then I should write f function of f pi 1, pi 2, pi 3, pi 4, pi 5, pi 6, pi 7. Did you understand this one? Is equal to 0. See here, this equation, did you understand? Here it is written n minus m. N minus m means how many?
Up to 7.
7. Up to 7 you have to get. Means how many dimensionless group you are getting at last?
7.
7. Now you understood the problem statement?
Yes, sir.
Yes, sir.
Please take the statement of the problem and take this derivation. It's very, very important. And still, if you are not understanding, again you will be understanding while solving the problem. But at least try to understand what is n, what is m, and what are pi terms. M means fundamental dimensions involved in a system. N are the number of variables, both dependent and independent variables involved in a system. Then finally we are taking n minus m. They are called as a pi terms or the dimensionless groups, and those pi terms are being expressing in a functional relationship. Then after expressing the functional relationship like this, if you are writing a function, then each pi term is to be solved. Each pi term is a dimensionless term and is independent of the system. And division or a multiplication by a constant does not change the character of the Python, because it's a anyway it is a dimensionless. If you are dividing or with a multiplication, it doesn't change the value of the pi term. Okay, remember, each pi term contains m plus 1 variables, where again I'll come back to this one. What is m plus 1 variables? Each pi term contains m plus 1 variables, where m is the number of fundamental dimensions and is also called repeating variables. Okay, very important term, repeating variables. Just note it down, the repeating variables. Again I'll come back to this word. What are repeating variables, how to choose the repeating variables in a pi term. So this plays a very important role while solving the problem, that is the repeating variables. And whenever you are writing the pi terms, each pi term will be containing m plus 1 variables. M is the fundamental dimensions. They are 3 numbers. 3 plus 1, 4. Every time 4 variables will be always present. Every time m plus 1 variables. 3 plus 1, 4, like this. And where m is the number of fundamental dimensions and is also called as a repeating variables. Every time it will be repeating in each pi term, hence it is called as a repeating variables. Let in the above case x2, x3, x4. Suppose in the above case, this case, if you are taking x2, x3, x4 as a repeating variables, just for example, I am taking this x2, x3 and x4 are the repeating variables. If fundamental dimensions m, they are m lt equal to 3, then each pi term is written as, how it can be written? So I hope you understood the statement here till from here to here.
Sir.
See, I'm writing the pi terms. Then the pi 1 can be written as, there are, for example, there are 7 pi terms we are getting, they are dimensionless. Then the 7 pi terms you have to solve here. Pi 1, pi 2, pi 3, pi 4, 5, 6, 5, 7, 5, 8, like this. You go on solving the pi terms just by selecting the repeating variables. And here in this example, I am selecting x2, x3, x4 are the repeating variables, just for example. Okay, x2, x3, x4 are the repeating variables. There are 3 repeating variables, and these 3 will be existing in each pi term. See here, x2, x3. Are you getting here? x2, x3. You all can see, right? I'm highlighting here. Can
Yes,
you
sir.
see in each pi term? Because I'll come to know that there are 7 pi terms are involving in a system. So I am go on writing pi 1, pi 2, pi 3 till pi 7. Then whenever I'm writing the expression for the pi 1, I have been selected x2, x3, x4 as the repeating variable. These will be repeating in each pi term, so that those variables to be written very first. x2, x3, x4 to be written first. Then you have to write the powers a1, b1, c1. I hope you are getting, like release method only, same. Just you are getting a 7 terms here, 7 pi terms. So for each pi 1, so pi 1 means you will be getting a1, b1, c1, like this. I hope you are understanding.
Yes, sir.
Okay, so you are getting a 7 pi terms. So I am writing a pi 1 here. You also write here pi 1 term, x2 raised to a1, x3 raised to b1, x4 raised to c1. And again I said, see, each pi term contains how many variables? Each pi term contains how many variables?
M plus
Yeah, plus 1.
Yes, m plus 1. M means how many here?
7.
3.
3. Pi terms are 7. M means fundamental dimensions. 3.
Yes.
3. M I have been selected here as x2, x3, x4. How many are there? Example, x2, x3, x4 are 3. Plus 1, plus remaining. That plus 1 means this x1 is a plus 1 term. See, 1, 2, 3, plus 1 x1 remaining. Similarly, pi 2 term, x2, x3, x4. Again, these will be repeating every pi term. These will be repeating, hence they are called as a repeating variables. Again, but since it is a pi 2 term, you have to write x2 raised to a2, x3 raised to b2, x4 raised to c2, then the remaining will be x5. Likewise, if I want to write pi 3, can anyone tell how to write pi 3? Can anyone tell how to write pi 3?
X to power a3.
First, write x2, x3, x4. These will be remain same in all the pi terms. These should be written same. Then x2 raised to
b3.
A3 here,
B3.
B3.
here,
C3.
C3.
correct. Then the remaining m plus 1 more variable, x
X1.
6. Don't take, already you have taken x1 here, okay, and x5 you already taken. The remaining is what?
X6.
Correct. X6. Similarly, suppose if you want to write pi 4, tell me pi 4.
X2 raised to A4.
So first I'll write x2, x3, x4. Okay, now tell me. A4,
B4,
B4, C4, and one more, plus 1.
X7.
7.
Correct, exactly right, x7. Because already you have taken x1 here, and already x2 is there, x3 is there, x4 is there, x5 is there, x6 is there, and left out is x7.
Yes, sir.
Understood? Understood like this?
Yes, sir.
Okay, this is what we call as a Buckingham Python. Please mute your audio. Okay, I hope you understood the procedure.
Yes, sir.
Please try to understand. So like this, till x pi n minus m term you have to take and solve the problems. Okay, then how to solve the pi terms, again I'll come back to you later. At this moment of time you may not be understanding, at least you try to understand the derivation here. Just this is the derivation of an pi term, Buckingham pi theorem. When I take a problem and when I'm taking the n number of variables, m number of fundamental dimensions, then the pi terms, when I'm keep on solving, you'll be understanding this method very clearly. But for this moment, you try to understand these derivations here. Okay, so once you return pi 1, pi 2, pi 3, pi 4, pi 6, pi 7 like this, then each equation is solved by principle of dimensional homogeneity, and again same as you are done with the previous method, release method. A1, that is the powers to be calculated, so A1 B1 C1 A2 B2 C2 A3 B3, every time every pi term to be solved, and by equating the powers on both side, LHS side as well as the RHS side, by writing the dimensions. So you have to solve A1 B1 C1 etc. are obtained. These values are substituted again back to the above equation, and the values of pi 1, pi 2, pi 3 up to pi n minus m are to be obtained, and these values of pi's are substituted in the equations. Then the final equation for the phenomenon is obtained by expressing one of the pi terms as a function. So like this, pi 1 is a function of so and so, pi 2 is a function of so and so. Like this you have to express the equations. Okay, I hope you understood this much here. Okay, still if you are having any confusion, that can be cleared when I take a problem, numerical problem, and solve. There you can understand easily. So please all of you note it down, the statement of the problem here. Please all of you take the statement. Please take this statement. Here I'm highlighting these words are very important. Repeating variables, m plus 1 variable, this is very important, and pi terms. Then the highlighted words are very important, and here also this one up to here, this is very important statement. State Buckingham pi theorem method and explain it. Explain means this is the explanation. You have to take the variables like x1 x2 x3 up to xn, then out of these variables you have to select which is dependent variable and which all are independent variables. Then among these variables you have to choose m number of fundamental dimensions. Then finally you have to express n minus m dimensionless groups, and those dimensionless groups are called as a pi terms. Then you have to solve pi terms, each pi terms just by taking the repeating variables, and those repeating variables are equal to the number of fundamental dimensions. There are 3 repeating variables generally, and how to choose those repeating variables we'll see in the next section. And those repeating variables will be repeating in each pi term, pi 1, pi 2, pi 3, every pi term they will be repeating, hence they are called as repeating variables. And each pi terms will be having m plus 1 variables. M means the fundamental dimensions. Every time those will be appearing in each group, and like this here they are appearing like this. Then you have to go on taking that variables, and then you have to write the exponents. Then you have to solve the exponents, and finally you are getting the pi 1, pi 2, pi 3. They are called as a dimensionless groups or pi terms. Is it clear? Are you writing? Shall I go to the next one, or you want me to wait?
Sir, wait, sir.
Is it clearly visible?
Yes, sir.
Just you can zoom it in your mobile. You can visible. It can be visible. Okay. Is it over?
Yes, sir.
Is it over?
Yes, sir.
Okay. Right. Next, very important part is method of selecting the repeating variables. As I said previously, repeating variables. How to choose these variables in an equation, and there are some criteria to choose the repeating variables, and you have to keep in mind these criteria for selecting the repeating variables. You cannot select randomly the repeating variables, and there are some criteria, or you can call it some methods to choose the repeating variables. And how to choose the repeating variables here? See here, the number of repeating variables are equal to the number of fundamental dimensions. First point. Always remember, the number of repeating variables will be equal to the number of fundamental dimensions. How many fundamental dimensions are involved in the system? Those many number of repeating variables you need to choose. Suppose there are two fundamental dimensions. How many repeating variables?
2.
2. Suppose if there are 3 fundamental dimensions, how many repeating variables?
3, sir.
3. Okay. So as we know, the fundamental dimensions are M, L, T. M, L, T. There are 3 fundamental dimensions, and there are those many number of repeating variables to be taken. So that is the first step. The number of repeating variables are equal to the number of fundamental dimensions. So please all of you note it down. This also is very important. They will be asking in a many time exam. Write about the repeating variables, how to choose the repeating variables, method of selecting the repeating variables. So many times this question will be asking how you will be choosing the repeating variables in the Buckingham Pythagora method. See, the repeating variables are equal to the number of fundamental dimensions of the problem. Then the choice of repeating variable is governed by the following considerations. So what are those considerations? So the first consideration is what? As far as possible, the dependent variable should not be selected as a repeating variable. I hope you understood what is a dependent variable. Correct? Huh? In a system, which variable you have choosing as a dependent variable, that should not be taken as a repeating variable. Is it clear? First one.
Yes, sir.
So in which variable you are taken as a dependent variable, that variable should not be taken as a repeating variable. That is the first step. Second one, the repeating variables should be chosen in such a way that the variable contains, see, the geometric property. See, variable should contain the geometric property, and other variable contain the flow property, that is kinematic property, and the third variable should contain the fluid property, that is dynamic property. So geometric property means what? The linear dimensions. Are you getting my point? How to choose?
Yes, sir.
The repeating variable should be chosen in such a way that the first variable should have a geometric property, second variable should have a kinematic property or the flow property, and the third property is the fluid property or the dynamic property. The geometric property means the length, diameter, height, depth, like this you have to take. That is the linear dimensions. Are you getting a point? Geometry. These are the geometric property. Like this, if you are having in the problem, you can choose any one as a geometric property. Correct? Understanding? Variable with geometric property. Second property is what? Flow property. Flow property means what? Velocity, acceleration, discharge. These all are the flow properties. The variables with the flow property are what? Velocity, acceleration, discharge. Like these properties are called as a flow property. Then the variables with the fluid property means the dynamic properties are what? Those who have got involved force, that is viscosity, density, weight, like this. They are called as a fluid properties. Specific weight, such kind of property is called as a fluid property. So whenever you are choosing a repeating variables, one to be taken from the geometric property, one to be taken from the flow property, and other to be third one to be taken from the fluid property. I hope you're understanding. So suppose in the previous problem, the variables involved are R, density, mu, L, V, and G. How many variables are there here? How many are there?
6.
6. N equal to how many?
6 number.
6 number. And M equal to how many number?
3.
3. Then N minus M equal to how many?
3.
3. And these 3 are called as a pi terms. These three are called as a pi terms. Okay, pi terms. Okay. Then how many pi terms I should get? 3. Pi 1, pi 2, pi 3. Okay. Then I have to write the expression for the pi 1, pi 2, pi 3. Then first I need to write repeating variables. How the? Yes or no? First I should write. Okay. Then what is the criteria to choose the repeating variable? In this problem, you are taken in a release method. In this problem, which is the dependent variable? R is the dependent variable. Yes or no?
Yes, sir.
This should not be taken as a repeating variable. Leave this one. You should not. Only you have to choose among 5 repeating variables. But to choose that repeating variables, what is the criteria? What was the first criteria? The dependent variable should not be taken as a repeating variable. Then the next criteria is what? One to be taken from the geometric property. Which is the geometric property gives here? Which one?
Yeah.
Correct, exactly. L is the geometric property. I should write L first. Then which is the flow property here?
Velocity.
Correct.
Viscosity.
No, flow property. Flow property which doesn't involve any force, mass.
Velocity.
Exactly, velocity is the flow property. What is the fluid property? Either you may take a density or viscosity. Any one you can take. I'll take as a rho. Understood? All of you understood?
Yes, sir.
See here, I am choosing the repeating variables. So what is the criteria? As far as possible, the dependent variable should not be taken as a repeating variable. Then the remaining from the remaining variables, which are how many variables are remaining? How many are remaining? 5 are remaining. Out of 5, you have to choose 3 repeating variables. But what is the criteria to choose the repeating variables? One should be geometric property. Correct. Second, flow property. Third,
Fluid property.
correct. Now, among these 5 variables, which is geometric property? Means linear. Length is geometric property, right? Correct. What is the flow property? Velocity is a flow property. What is the fluid property? Either density or viscosity. Yes or no? Anyone you can take.
Yeah.
That is left to the person who is testing in the laboratory. That is left to him how he choose the repeating variable. But you have to follow the criteria. What are those criteria? First.
Should not it should not be dependent
Correct.
variable.
Correct. Next.
It should contain geometric property,
Correct.
fluid
Correct.
property, and flow property.
Exactly. If you keep in mind these things, then you can easily choose the repeating variables while solving the problem. All of you understood?
Yes, sir.
Yes, sir.
Right? One is from geometric, one is from the flow property, one is from the fluid property, and as far as possible, the dependent variable should not be taken as repeating variable. Okay, so these are the criteria. These are very, very important. Are you noting it? Are you writing?
Yes, sir.
Please write this one up to
Yes,
your
sir.
end. Okay, third one. I'll tell you third one. The repeating variable selected should not form a dimensionless group. Means when you are forming a repeating variable like this L, V, rho. So this group should not form a dimensionless. Means suppose if I substitute the unit here. What is the unit of L? Meter. What is the unit of velocity? Meter per second. What is the unit of density? Density? Kg per? Kg per meter cube, right? Correct, huh? Okay. So the meter get cancels. What is the final answer you get here? Kg. Yes. Kg. Tell me. What you get?
kg second per meter.
Kg per second meter, right? Yes or no? So is it non-dimensional or dimensional?
Dimension.
Yes, dimensional. Means what is the meaning of this one? The repeating variable selected should not form a dimensionless group. Means when you take that together, all together, it should not form non-dimensional group. Means you should not get one. It should be dimensional. Understood?
Yes, sir.
then the repeating variables together must have the same number of fundamental dimensions. Okay, so same fundamental dimensions means, suppose kg means what? Is it mass or length or time? Kg.
Mass,
Is it
sir. Mass.
then I can write m, right? Then meter means
Length.
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 L raised to minus 1, correct? Then second means time.
Time.
So all three are present. All three are present.
Yes, sir.
MLT present
Yes,
or
sir.
not? Okay, that is the fourth one.
Present.
The repeating variables together must have the same number of fundamental dimensions. Understood? All of you understood?
Yes, sir. Yes, sir.
Then fifth one, no two repeating variables should have the same dimensions. Means you should not select, suppose in this problem itself, if suppose diameter also present, let us understand diameter, you should not take both L and D. Understood? No two repeating variables should have the same dimensions. Understood?
Yes, sir.
Yes, sir.
It should be one from geometric, one from kinematic, other is the flow property, one from fluid property. So these 5 points you should remember. So in most of the fluid mechanics problems, the choice of repeating variables may be like this. Most of the fluid problems, just to remember this one. One is a geometric, velocity, density. Again, length, velocity, density, or length, velocity, viscosity, or diameter, velocity, viscosity, like this. Understood? So this is how we can choose the repeating variables. Understood, all of you? Please note it down, this repeating variable procedure. Please note it down, all of you. Then I'll come to the procedure to solve the problems by Buckingham Pythagora method. You write, all of you, method of selecting the repeating variables. All of you write down. All are writing. 5 points you write. 5 points you write. After completing, you just tell me. Over. You can take a snapshot also, and then you can enter in your notebook. Okay. See, this is the procedure to solve the problem. But don't miss the class. If you miss the class, you will miss the concept. Okay. So, yes sir, no.
Yes, sir.
Okay. So tomorrow I'll take the statement. First I take the statement of Buckingham, and with that statement I'll take a one problem, same what we have solved in release method. The same problem we'll take and solve by Buckingham Pythagora method. You will understand the difference between the release and the Buckingham Pythagora method. Okay, the same problem we'll take and understand. We'll solve some 3-4 problems. Then we'll wind up this method and we'll go for the model analysis and how dimensional analysis can be utilized in preparing the models and how to do the model analysis. The next part of this module will. Okay, so tomorrow I'm taking the class. Please, all of you, solve the problems, try to understand the number. If you go on solving more number of problems, then only you will get the doubts, and that doubts can be cleared in the class. Okay, so unless and until you practice the problems, you cannot understand the concept also, you cannot understand the subject also. Please, at the end, last moment, don't keep till the last moment. Please, it is a beginning only. You just start solving the problems, and any difficulty can be discussed in the class. Okay, if you are solving problems, you can send me the solved problems. If you are stuck in between, you can WhatsApp me, and I will check and send you back. Okay, again I'll provide you the questions also, assignment questions. Then you can keep on solving the problems. Okay, so tomorrow I'll continue. So if you have any queries, you can raise, otherwise you can leave the meeting.